With this being a video, be sure to pause, give yourself the time you need to write things down, and all of that. At the start, get your information filled in here. And today we're going to be working on geometric solids, specifically about them, the surface area and volume. And the cool thing about this is you're going to get practice drawing these shapes too. When you look at this sheet, you'll see that solid is on the left column. In the middle it says surface area, and then on the right volume. These spots are going to be where our formulas go, and then here is where our solid is going to go. Now when you're talking about different solids, kind of the most basic one to start with would be the cube. So I'm going to line my ruler here, and then I'm going to slide it down so that I'm staying parallel to that line. And I want to budget enough space to where I can be neat and draw a cube. But if I do draw a cube, I'll need to start with 1. Now, I did go from 3 to 4 there. If you did go from 2 to 3, it doesn't really matter. That's totally fine. But if I make this a 1 by 1 by 1 inch cube, it might be a little bit more manageable. Now I'm going from 4 to 5, and you'll see how I have this tick mark that's larger on my transparent ruler. I'm using that to butt up right next to the line. So take your time doing this and pause yourself, and pause the video if you need it, so that I can imagine this line being drawn all the way through. And that neatness and that patience is going to get it to where I have a very close to 90-degree angle there. You can go above. Sometimes going above is a good call. Sometimes it's a mistake. When it's a mistake, it's because, like, if you put too much pressure. If you draw past something, no big deal. Fix it up. You can use an eraser. And then for those last 2 lines, because I had drawn it pretty accurately, I was able to go like that. Now imagine this 2-dimensional shape kind of getting pushed into the page. So it's going to be kind of like 3-dimensional that way. But the way you're going to do this is you're going to draw your lines at the same parallel nature. So when you move your ruler down, you're trying to maintain that same angle without swiveling and changing it too much. There's many different ways you can draw this. So I'm going to start parallel with this 4, 5, and I'm going to come up a bit and over. And when I like the way that looks, I'm going to go from 4 to 5. Perfection isn't really necessary. But then here I'm using my transparent line, kind of a different strategy now, so that it would go through there. And from 3 to 4, I'll draw another 1-inch line. And then this is that parallel deal I was hinting at. This would be visible, so I'll make that solid. If I moved it up like that, it should connect appropriately. Make it solid, and make it solid. But to communicate that this is a cube, we can be extra cool by doing a dotted line. And then if you go past this corner, that's fine. Just know that you'll erase it. And then from this tip, drawing another dotted line. And then if you use the ruler, great. If not, just keep it neat here, because I think that's good enough. So here we have really clearly drawn a cube. When we label this, you want to be clear, but if I label this first side as the variable x, if I'm telling you that this is a cube here, which I want you to go in and write in, we would know that by the definition of a cube, all of the different faces are the same. So if this is x, then so is that. Because volume is so much more clear, I'm going to move there first. Capital V equals, and it's going to be that side times its height. So it would be x times x times x. But since we're multiplying it by itself 3 times, it's x cubed. For the surface area, this would be that times that. So we'll write capital S, capital A, which is really just one variable, so it's kind of a rare example where you're just writing two letters, and it's going to be x times x is going to give us x squared. But this would only be for the one single face. And since a cube has 1, 2, 3, 4, and then the back, 5, and the front, 6 sides that are all the same, the surface area for all those different sides would be 6 times x squared. Now we made this 1 inch, but let's pretend it was 5. So now we'll sneak this in and we'll see what it looks like with an example. And I'll use 2 tick marks, and that'll be inches. So for this problem, since x is 5, rewrite 6 times 5 squared. Bring your equal sign down. 6 times 5 squared is 25. And then 6 times 25 is going to be 150. And if this was a paint problem, I would paint surface area. So I would need square SQ period IN, since they told us it's inches. And then for that, we get an example of this type of problem. Volume, same ideas apply. The value of x is 5 inches. So I bring my equal sign down. I write 5. We're going to cube it. And 5 times 5 is 25. Times 5 once more is 125. But for this one, I will write IN cube. And then box it. And then we'll make a little arrow and we'll say or cubic inches. So we have that called out as well. So we're clearly breaking apart this shape from the previous. I'm going to use my ruler. We're going to line it up. And I'll do my best to kind of mimic a parallel line to that, so that now I have my cube as my first solid. And now we're going to move on to, typically what we could call a box. But in geometry, we would call it a rectangular prism. Now after you write RECTANGULAR say it out loud to yourself, rectangular prism. And that way you'll be practicing verbalizing it, and maybe locking it in a little bit better. So here we have to kind of budget our space a little bit more smart, because when I make this box, it's going to kind of go deeper into my page. So here I'm going to draw some distance, but I'm not going to be perfect about it. Like, I'm not going to tell you it has to be 1 1/2 or 1 3/8, but I'm probably taking about a little bit more than half of this window. And I'm keeping my ruler parallel to this shape, and I'm going to slide it up this time. And I'm using pen, so I don't want to go past. But if you go too far, that's okay, because what we're about to do, you're going to line this up, and remember that tip about trying to get the line to look like it's going through and picking up where the tick mark leaves off. And there's the first part of our box. Now this time I'm going to go about it a little bit differently, and on purpose I'm going to mess this up to show you how you would just use your eraser. So we're going like into the page, and I'm going to slide it down, slide it down, slide it down. And I think I mostly like this angle. Slide it down, trying to keep those parallel lines. And then I'm going to come up at this point. But now this point is going to drive how I do my other one. So I'm coming up. See how I've got that going through 16? Sliding, sliding, sliding. Saying it 3 times for some reason, like that helps. And then I'm going to go here. And if you go over, erase that part that crosses. And this is going to be the rectangular prism. You'll notice that mine's a little bit imperfect, and that's fine. Don't sweat it. But let's label this guy. Often we think of the width as being the front Length is going back into our page, and that's where we're making slight cursive L's to represent length. And then height, same deal. If you can give it that cursive look, great, because this is going to be what's typical of geometry. This height is also here, and it's also here. So imagine this was a shaded in face. We would know that the area would be width times height. But now, that face, picture it going deep into the page. And as it goes deeper and deeper into the page, it starts to fill in and get its depth from this. So it would be width times height, and it goes back L. So the volume is going to be L times W times H. And we could break this up into cubes if we wanted. I'm not going to have you guys do this. But volume-wise, I can see how its entire volume would be created by cubes. And since I made this one 4 long, go ahead and write W equals 4. You don't have to sketch it up, but you do want to add that. Give it a length of 3, and then a height of 4. So when I plug in the values for this one, length is 3, width is 4, height is 4, and I only wrote 3 first to keep the order. If you just saw it and you're like, I just want to do 4 times 3 times 4, that's totally fine. And then 12 times 4 is 48 cubic inches, or we can put inches cubed. So we'll go back and sneak inches there so it's consistent. And we'd box that. Same deal as before, we also could say or cubic inches. Now surface area is a little bit different. This very first face right here would be width times height, because we would do W times H. This face would be length times height, because you would go 3 deep and 4 up. But then our top face would be 3 times 4. So each of them is just slightly different. But when we put it all together, you're going to get 2 times length times width, because each particular one gets repeated a bunch of times. So here's that top face. It would also be down here on the bottom. Plus 2 times WH, because here's W, here's H. This face would show up not once, but also in the back. So that would be its surface area on the outside, because it's the area on the surface of the shapes only. And then plus 2 LH, because you have length times height. So you get this face and then the face that was over here. So everything shows up, and you got 1, 2, 3, 4, 5, 6, which matches the 6 up here, because each face of like a rectangular prism should have 6 total sides. And then we could just plug in all the different values here. LW, 3 and 4. Oh, the lights went out. Let me stand up for a second. Sorry about that. So we got 2 times 3 times 4 plus 2 times 4 times height is 4 plus 2 times 3 times 4. And a lot of different ways you could do this, but 6, 4, 24 plus 32 plus 24. Then I'll do 48, combining these guys. And then what do you get? 80 square inches. And then this could also be or inches squared. You'll see it both ways. I do think it's important to build these resources. It makes you think about what you're drawing, puts a picture behind it, and I feel that that's applying your knowledge, which is way better than letting a resource just be made for you from a printout. So we've done a solid, we've done a rectangular prism. Let's go on and do a sphere next. This is where I was talking about gross versus fine motor. If you try to like perfectly do a sphere, it's not going to go super perfect. So that's why I try to make it a quick gesture. S-P-H-E-R-E, sphere. And then, just like the globe, what people are really interested in is the distance around it. And so that's going to be the circumference. But as I make this arc here, that would be like the hemisphere, the equator, excuse me. And then now make a dashed line because it would go through there. But in the center there would be some point that would go outwards to all the different directions. That would give the sphere its shape. And this would be the radius. So the distance from the center of a sphere to its outside is the radius. And by the way, the globe is not a perfect sphere due to its spinning. And let's move on to surface area. 4 pi r squared. And we'll probably want to make a note that pi, the Greek letter, is approximately 3.14. And you'll notice that you don't write anything after 3.14 because it's just a number. It doesn't have any units at all. So there's 4 pi r squared, and the volume, which we're just going to end up memorizing over time, but not today, is pi r cubed. So volume is 4/3 pi r cubed. So if I told you that this was 10 centimeters, we can use that number and plug it in. 4 pi times 10 squared is equal to, you can multiply in any order, so 4 pi and then 100. And now we're going to do 4 times 100, and we're going to write 400 pi. Now we've talked about how this number right now is accurate. That's why I can use an equal sign. But what I'm typing in now is something into my calculator, and I'm typing 400 times 3.14, or in your calculators you can use pi. But the problem is once we write it down, we have to round it, so we're going to use 2 wavy lines for an approximate symbol. And when I do this, I get 1,256 centimeters. Leaving it as centimeters wouldn't be true because that would just be a distance. This would have to be like paint covering the sphere. So you're going to add an exponent of 2 on centimeters to communicate that it is centimeters squared. And if you look back at the formula, don't write this here, so I'm going to put an X, meaning don't write this. This radius, that would have been measured in 10 centimeters times 10 centimeters, and centimeters times centimeters would be a number times itself. So that's where you get that square unit from. It's kind of going a little bit back and forth, adding a couple layers every time. Rewriting 4/3 pi, but now we got, instead of just 10, it's 10 cubed. And so we're going to do 10 times 10 is 100, times 10 is 1,000. And if you feel comfortable, you know that 1,000 times 4 is 4,000 pi, but that would still all be over 3. I just push this 3 down here because it's still being divided by 3. It's in the denominator, while 4 is being multiplied by 1,000. That was in the numerator. And then now here's where we're going to have to do some rounding. 4,000 times 3.14 divided by 3 gives me 4,186.7. There we are, rounding to the nearest tenth. And then I'm going to say centimeters cubed. Or cubic centimeters. cm, centimeter, that's the typical prefix, abbreviation. And then the other thing I'll remind you guys of is up here we had radius. Again, don't write this. But if we had radius, it would have been centimeters times centimeters times centimeters, which gives you that cubic centimeter that we could use to approximate the size of this shape. I feel like this has been a pretty good chunk for today and a lot of time, so let's stop this video here and we'll add more shapes later.